Okay, so section 4.2 deals with what they call the simplex tableau method, which is a method for finding minimum or maximum, usually profit. You know, you want to maximize your profit, minimize your costs by setting up matrices, or what they call augmented matrices. And I'm going to get you started on this in this video, and I'll probably post a second video just kind of showing you how I use the program simplex. Just from my perspective, because it's kind of one of these things you have to take on faith that it works, and you don't know the reasoning why, and so you just have to kind of learn the process. So what it is first thing we have to do is set up what they call an augmented matrix, which is actually pretty easy to do. When you have three variables, you set them up for the number of variables you have, but I've got an X, Y, and Z and a number. And so you always want to have the variables on one side and the numbers on the other. And you make a matrix out of those things. Hold on, let me annotate. So like, you know, this is the coefficient 1. So X is 1, Y is -2, Z is 3, and that equals 72. So you see how I'm just turning all the coefficients into a matrix. So the second row would be 1, 1, 1, 4. The third row would be -3, 22, -2, -10. All right, so this is what they call an augmented matrix. They put a little bar here that you don't really write that, but that's just to show you that your solutions are over here. Okay. All right. So since she talks about what I just said, all right. So if I want to make an augmented matrix out of a system of equations, you have to make sure like the x's, the y's, and the z's are all lined up. So they are in this case. So basically all I do is make a matrix. The first equation, the coefficients are 3, 1, -2. Oh, no wonder I'm writing on that. Come back here, pen. 3, 1, -2, and the answer is 2. And then I do 1, -2, 1, 3, -1, -1, 3, 6. So this would be the augmented matrix. You can put this bar here if you want. All right. Put the dimensions of this matrix just to kind of remind you there's 3 rows and there's 4 columns. All right. And you could enter that hopefully in your calculator at this point. All right. So this is what she's saying here. Obviously, the X, Y's, and Z's need to be lined up. If they're not, we need to put them so that all the X's are in column 1, the Y's are in column 2, and the Z's are in column 3. Okay. And if there's nothing there, like if I don't have an X or something, then you put a 0. Okay. All right. So now we're going to set up an equation, you know, for A, B, C, and D. So you just got to put them in order. So if I were working with this equation, give me my pencil. It's fine. All right, so I want to put this equation in order. So I'm going to move the x over to the other side to make it positive. So if you move it over, you're adding x. So x becomes positive. So this is x plus 2y. And then the 3z is going to get moved over. So whenever you move anything over, you change the sign. So it's minus 3z. And the 4 has to be moved over to the other side, so it becomes positive 4. Anytime I change signs, I just change sides, I just change the sign. So if I set this in order, A is 1, B is 2, C is -3, and D is 4. Now, there's another solution to this. If I kept X on the right-hand side, right, X would be -1 now. Y would be -2y, moved Y over. So there's more than one way to write this, but that would still do the same thing. So if I did it that way, X is -1, Y is -2, Z is 3, and D is -4. And these actually represent the same equation, so it doesn't really matter. Okay. I just like X to be positive. All right, so I'm going to move the 8X over. So 8X minus, I've got 3Y, and I'm going to move the 5Z over, so that becomes negative. And then I have the 7 that has to move over, so it becomes a -7. Anything that changes sides changes signs. All right, so this is 8, -3, -5, -7. Okay, so a couple more examples. We're going to move the x's over. I'll just keep it on the left-hand side. It doesn't matter. I'd rather just move the y because it's going to be a lot easier just to move the y. So this one I have negative 5x. The y needs to come over with the x, so I'll make it minus y. And then I've got a 9z. Just put them in alphabetical order, equals negative 8. So the first variable is negative 5, negative 1, 9, negative 8. Okay. So with this equation, you'll notice you have an x and a z. You don't have a y. So all you're going to do is treat this as 2x plus 0y, because 0y is just 0. So for my coefficients, they'd be 2, 0, negative 1, 6. Okay, so if it's missing a variable, just put a 0 in there. All right, this next one, I guess I'll move the x over. So it becomes a negative x minus 7y plus 4z. Now, what am I left with? Well, nothing. So we call it 0. But basically, think about it. I'm subtracting x off each side. So x minus x, yeah, that's 0. So x is negative 1. That's a y. That's not an x. X is negative 1. Y is negative 7. Z is 4. D is 0. Okay? So this is just learning to get everything in order, x, y, z, and then the solution to get you set up for augmented matrices. Okay. So now what we're going to do is we're going to take some equations that may not be in order. We're going to put them in order, and then we're going to set up an augmented matrix. All right. So I'm going to write. All right, so the first equation, yeah, x and y and z are out of order, so I'm just going to mix them around. So 4x plus 6y minus 3z equals 30. X, y, z. So here, second equation, negative 2x. 5y is going to move over, so it's going to become negative. Change the sign. And I got 7z. Now 20 has got to go moved over to the other side, so it's going to become a negative 20. Okay. And this third equation, now be careful, the negative goes with the x, so it'd be negative x plus y. The z moves over, so we change the sign, so it becomes minus 9z. And if I move the 40 over, the negative 40, it's a negative you're moving over, so it becomes a positive 40. Okay, so our augmented matrix, just write it out. 4, 6, negative 3, 30. Negative 2, negative 5, just drop off all the variables. Negative 20, negative 1, 1, negative 9, 40. Okay, and they put this bar here. It's, yeah, it's just there. All right. All right, we got a couple more to do. So again, I'm going to line these equations up so that they look pretty. I'm going to put x, y, z. So the x, well, actually, you know, the x and y look pretty good. I think I'll just move the z over, right? So the 8z becomes a minus 8z. So what I have is 2x minus 5y minus 8z equals, well, what's left over is negative 7. That's the first equation. Oh, let's see. So the second one, I have a negative x right here, a positive 2y. I'm going to move the z over, so it becomes a minus z. And the negative 4 has to get moved over to the answer side, so it becomes a plus 4. Okay, so this last one, I have 6y. The 4z is going to get moved over, so I'm going to minus 4z. Well, guess what I'm left with on that side? Absolutely nothing. Okay. And now I don't have an x, so I'm going to make it a 0x. Okay. So now I'm ready for my augmented matrix. 2, -5, -8, -7, -1, 2, -1, 4, 0, 6, -4, 0. Okay, and we can enter it as a 3 by 4 matrix, and we can use simplex on it when we need to. All right. All right, so this next one looks like we got x, y, and z. Okay, so the first equation, I have a -3x. I don't have any y's, so I'm going to put 0y plus 8z equals 2. Let's see, I have the second one, I have a -x, so it's -x plus 1y plus 0z, no z's on the second equation, equals 1. Last one, there's no x, so it's 0x plus 6y minus 4z equals 0. All set up, so we write the matrix. -3, 0, 8, 2, -1, 1, 0, 1, 0, 6, -4, 0. Okay, and there's our augmented matrix. All right, so a slack variable. A slack variable is basically a leftover. I'm using something to make something, and I use so much flour, and maybe I have 5 cups available, and I use 3, so I've got 2 cups left over. So a slack variable turns an inequality into an equality, and it's really just the amount of leftover resources that we didn't have to use because maybe we didn't need them. All right, so we're gonna see what she's doing here. Okay, Jerry is buying pizzas for $6 each, okay, and sodas for $2 each. He has a budget of $68. Fill in the miss. Okay, so we're just filling the chart. So if I'm buying 3 pizzas, let's see, where's my pen? For $6, I'm going to pay $18 for pizza. And I'm buying 12 sodas for $2. I'm going to spend $24, 12 times 2 on the soda. So the total amount of money he's spending is 24 plus 18. That's the amount he spent on pizza and sodas. So it's $42, which he's got money left over. So the money I have left over is 68 minus 42 is $26. So that would be my slack variable. It's my leftover money. All right, so I don't think I need to do all of these. Let's do a few of these. Let's do this one. So if I buy the price of a pizza and 5 pizzas, 6 times 5, I'm going to spend $30 on pizza. And $2 for 16 sodas. So I do 16 times 2. I'm going to spend $32. So I've spent a grand total of $62. So I have 68 to spend. So my leftover is $6. Okay. All right. Let's see. So let's just do it again. 6 times 5 is 30. 2 times 18 is 36. I get $66, and my leftover is $2. All right, so now as an equation, the number of pizzas is varying, so we'll call that X. And so is the number of sodas, so we'll call that Y, right? We just do the same process, though. So we multiplied these guys, so this would be 6X. We multiply these guys, it would be 2Y, right? So the total spent would be 6X plus 2Y. And we have some money left over. That's my slack variable. So to write that equation, it'd basically be 6X plus 2Y plus the leftover money, which they're going to call S, equals 68. Okay. Oh, oops. I should read the questions. All right. Write an expression representing the amount of money Jerry will spend on X pieces and Y drinks. Well, we just did that. Okay, so let's write that again. So we know $6 per pizza plus $2 per soft drink. Okay. Now, the inequality means that's the money I spend. I have 68 bucks to spend, so that tells me that 68 plus 2y had better be less than or equal to 68 bucks. Okay. Now, to turn the inequality into an equality, all I'm going to do is add the leftover money, which is what they call S. So if I take the money I spent plus my leftover money, which is the slack variable, that should equal $68. Okay. So the slack variables in a simplex tableau just turn the inequalities, the constraints, into equalities. So for every inequality, you always add a different slack variable. Oh, okay. Let's see. Okay. Takes up the slack. All right. So we'll do the same kind of problem. Judy's buying X number of pogo sticks and Y number of hula hoops for a party. Pogo sticks cost $20 each and hula hoops cost $10 each. Her budget for the items is $500 and the amount she spends cannot exceed $500. All right, so same problem. Let me fill in the chart. Hello. Annotate. All right, so if she buys 8 pogo sticks for $20, 8 times 20, she's going to spend 160 bucks on pogo sticks. And 15 hula tubes for $10. I do 15 times 10, that's going to be 150 bucks on hula hoops. So if I add those two together, I'm going to get 310 total spent. So the leftover would be $500 minus 310, or 190 bucks. Okay. So we'll do one of the three. We'll do this one next. So now we're going to buy 12 pogo sticks for $20. That's going to multiply to 240 bucks. And if she's going to buy 24 hula hoops for $10, that would be 240 bucks. If I add those together, I'm spending 480 bucks. And my leftover, 500 minus 480 is 20. Okay. So now, in general, the total for the pogo sticks will be 20 times the number she buys, plus 10 times the number of hula hoops, which is Y now. And the total spent is what I want. So I'll leave that, well, it's 20x plus 10y. All right. And then you have your slack variable in 500. Okay, so let me do this. All right, so the total money that she spends on X pogo sticks and Y hula hoops is just what we wrote down there. So the money on pogo sticks would be 20 times X. The money on hula hoops would be 10 times Y. And that's the money, okay? The inequality, the money I spend has to be less than $500. Less than or equal to 500. All right, letting S represent the leftover amount of money, write an equation. So basically all I got to do is add the leftover money. So if I take the money I spent, which is 20x plus 10y, add the leftover money, should equal $500. Okay, that's your slack variable. Okay. All right, so now the big thing is writing the inequalities. All right, we're gonna write these and I'll show you. I use tables with these. I'll show you that probably in my separate video, but let's take a look and work at them. So it says write an inequality that represents the following scenario. Okay. Oops. All right, it says Ralph is planting X acres of corn and Y acres of wheat. So I write that down. X equals acres of corn and Y equals the acres of wheat. He owns 180 acres. That's a total, although he won't plant all of it. So that's you'll have some slack. All right. Convert the inequality. All right. So the number of acres plus the number of coin. Let's write the inequality first. X plus Y, that acreage is less than or equal to 180. Right? So now what we're going to do is convert it into equations. So basically you add your slack variable. So X plus Y plus the leftover acreage, which is S, should equal 180 acres. All right, if Ralph plants 50 acres of corn and 70 acres of wheat, so that's X and Y, how much is unused? So you just plug in 50 for X, so 50 and 70 for Y, plus your unused acreage has to equal 180. 50 and 70 is 120. And you can solve that. You'll get S equals 60 acres. He has left over. Okay. So same type of problem. X plus Y plus S is 180. So this is X. This is Y. So 60 plus 90 plus the slack variable has to equal 180, right? I'm just using this equation right up here. So that's 150 plus the slack variable equals 180. So I'm going to get the slack variable is 30. So he's got 30 acres left over that he's not planting. Okay. All right. So let's take a look. All right. This is the type of problem that I really like to do a table. I'm going to do a table for this one. All right. So basically with these problems, let's see, how do I want to line these things up? I'm going to have leftover resources, right, in what I'm making. All right. So for these, I'm going to use a table. Let me get my thing up here. Okay, the way that I make my tables is I'm going to put up on this axis here, I'm going to put what I'm manufacturing, what items. In this case, it's baskets type A and type B. Or what I'm selling, let's put it that way. And here I'm going to write what I'm using. So I'm going to make a little table, okay, will help me organize my data, okay. So I'm going to go over here, and the type of basket we have type A and type B. That's what I'm selling, baskets. What am I using for those baskets? These are my resources. I'm using apples and oranges. So I'll go apples and oranges. Okay, and I'll call those X for apples and Y for oranges. Okay, the number of apples and the number of oranges. Okay, so X equals number of apples and Y equals number of oranges. I hopefully did that right. All right. So for basket type A, she uses 4 apples and 5 oranges. Okay, so you see I'm filling in my table. For basket type B, she uses 6 apples and 3 oranges. Okay. She only has 8 baskets. All right, so these are going to be our inequalities: 52 apples and 36 oranges. Calvin. Sorry, that's my dog. All right. So here's the deal. So we know I'm going to make another column for total. All right. So 4 type A. If Chloe makes 4 type A and 3 type, okay. So I'll fill that in later. She's got 8 baskets total. I'll just kind of put that there. I'm not, okay. She's got apples, 52 apples total. and 36 oranges. Okay. All right. So how many baskets will she use? Well, this is kind of a silly question. You got 4A and 3 type B, so she's going to use 7, right? And you've got a total of 8 available, so you have 1 basket left over. All right. So apples. So here's how I'm going to figure that out. So I have 52 apples. So she's making 7 baskets. So the number of apples I use, let's go here. So for type A, I use 4. Let's go down here. Okay. I have 4 apples per basket of type A. So I'm going to make 4 type A. So I'm going to use 16 apples for type A. And for type B, I'm going to use 3 apples, and I'm going to use 6 apples. Sorry, I'm using my chart, 6 apples, and I'm going to make 3 type B. So 6 times 3, that would be the total number of apples. So 4 for each type A and 6 for each type 3. So I'm going to get 16 plus 18 apples, and I need a calculator, I guess. 16 plus 18, she's going to use 34 apples. Okay, so we get 34. How many will be left over? So I do 52 minus 34. I get 18. All right, oranges. So again, for the oranges, she's using 5 oranges for each type of A, which is there's 4 of them. And she's using 3 oranges for each type B, so that would be 3. So if I add those 20 plus 9, I get 29. So she's going to use 29 oranges. How many will she have left over? Well, she's got 36 total. So 36 minus 29 is 7. So she'll have 7 left over. Okay. All right. And what this will do, it'll help you set up your constraints when you're doing simplex tableau. And I'll do a separate video on that. Okay. All right. Oh, okay. I have more to do. Shoot, shouldn't have erased it. All right. So let me go back to my chart here. Apples, oranges, type A. Let me make a little chart. Let's see. Okay. Annotate. Okay, we had apples, which I called X, right? Oh, no, they're calling the baskets A. All right, so we have type A baskets, which are X, the number of A baskets, and Y is the number of B baskets. All right. All right, and apples. So we had apples, oranges. So now I got to go back. So an A basket used, let's go read it, 4 apples, 5 oranges. Okay, so I'll write that in there. Hello. Four apples, 5 oranges, and a B basket, can't remember, so I have to go back up there. Uses 6 apples, 3 oranges. Okay. There we go. Six apples, 3 oranges. I have a total of 8 baskets available. I have, how many apples? I think it was 52 apples available. This is the totals. And I think, how many oranges? Was it 36? 52 apples, 36 oranges. Okay. I'm going to use my chart to help me. All right, so this is 36. All right, so how many baskets will she use? Well, I will use X plus Y baskets, right? Okay. Now, let's do the inequality. So the baskets basically are going to be X plus Y. I know has to be less than or equal to 8 because we have 8 total, right? All right, how many apples will she use? Well, she'll use, just read across the row here, 4X plus 6Y. The inequality, I know that if it's going to be down here in B, we'll write, I'm going to write it here. It's going to be 4X plus 6Y is going to be less than or equal to 52, right? And the oranges would be, just read across the row, 5X plus 3Y. All right, and if I want that inequality, I know that 5X plus 3Y is less than or equal to 36, okay? So the chart can kind of help you set up those equations so that they're not so difficult. Now, these are the inequalities, and I'm sure we're going to add slack variables to turn them into equalities. All right, so okay. So I'll start here for the slack variable for the number of baskets. I think we had already written it, but I'll write it in the blank. We know that the number of baskets is less than or equal to 8. All right, and here's the apples. That goes here. And the oranges are here. Oh, they want me to rewrite it using slack variables. Sorry. Okay. So these are my inequalities. Sorry for the mess. So what we're going to do is write some slack variables. So they usually call them like S1, S2, S3 because they're 3 different things. So for the baskets, I'll do that in red ink so you can see it. For the baskets, it's X plus Y plus a slack variable. I'll call it like, they write it like this, S1 equals 8. Okay, so the ones I use plus the leftover equal 8. So for the apples, it's 4X plus 6Y plus another slack variable, which is the leftover apples. I'll call it S2. That has to equal 52. And for the oranges, we're going to introduce another slack variable called S3. So it's 5X plus 3Y plus the leftover oranges, which is S3, has to equal 36. Okay. All right, so I am going to, when they say write constraints, they're saying write the inequalities, all right? So I'm probably gonna make a table with this. I like the tables because it just helps me organize my data. Okay, so I'm manufacturing 2 types of toys, toys A and B. That's what I need, come on. I don't want red, I'll do blue. All right, the stored owner, okay, so I'm gonna make myself a table. I have A and B. All right, in total. All right, so this is what I'm manufacturing. This is what I'm selling. The store pays $8 for toy A. So I'm going to write one for money. I'm going to usually write money at the end. That's the bottom dollar, right? $8 for A, $14 for toy B. That's their costs. Oh, never mind. The store owner estimates that no more than 2,000 toys will be sold every month. So that's a total. All right, so this is the number. And he does not plan to invest more than 20,000, so that's his cost. So 20,000, it's less than or equal to that. All right. The constraints, let's see. So the toy A is X and toy B is Y. That's right here. So pretty much you can just read across these columns. If there's no numbers, it's just a sum. So I know that X plus Y, that's the number of toys. It has to be, no more than 2,000, sorry. no more than 2,000. So that means less than or equal to 2,000. So these are what they call the constraints. They're my less than or equal to my inequalities, all right? This next one, I can just read across the row. It's 8x plus 14y is less than or equal to $20,000. All right, so these are my what they call constraints for a simplex tableau problem. Then all I would do is add two slack variables, S1 and S2, to turn the inequalities into equalities, okay? All right, so let's talk about reading these matrices. When you simplify a augmented matrix and get so that whatever you want is maximized, identity column is a column of one matrix that has 1, 1, and the rest are zeros. So like, I'm looking for basically ones across the diagonals. All right. No, sorry, she's just saying identity column, not matrix. So I'm looking for a 1 in all zeros. So let's take a look at this. Where's my pen? All right, identity column. Exactly 1, 1, and the rest are zeros. So I'm looking for 1, 1, and 0. So like this is an identity column, and this is an identity column. 1, 1, not -1, just 1. 1, 1, 1, 1. That has significance, by the way. All right, this is an identity column. Anything that's an identity column we're interested in. Okay, I think that's it. All right, let's see. Let's look at this one. Do I see any identity columns? No identity columns. All right. And so here's one, here's one, here's one, and that's it. Okay. So that's how we tell an identity column. It's going to give us an answer. That's what it's going to do. All right, let me go down. Oh. So one of the things you're going to have to do with simplex tableau, and I'll probably do a separate video on this. Let me clear this stuff off. Is you're going to have to figure out which is what they call the pivot row and the pivot column. Okay. Now the indicators, what they call an indicator, are the numbers in the bottom row. Now, when you do a simplex tableau, they're going to be the things you want to optimize. All right. So that's going to give you the bottom row. This is different than the rest of the matrix. So to find the column that you want to pivot on is you find the most negative number in the bottom row. That's called an indicator. So this right here would be the column that I'm going to pivot on. All right. So like if I look at this one, so this is the column. All right. So this guy, the most negative number is this guy right here. Okay. And let's see what else. This guy here, the most negative number is this one. So these are pivot columns. And this is a pivot column. Okay. All right. So we're going to find the most negative number on the bottom row of the matrix. And that's what I want for that. Now, we got to find the pivot row. Hopefully she'll talk about it. All right. So what do we pick? Because basically this program's you're gonna pivot in this program until a certain point is reached. All right. But first thing we gotta do is find a pivot point. All right. So what you're gonna do with a matrix, you're gonna have an augmented matrix and you're gonna generate these, and you're gonna find the most negative number in the bottom row, and that's the column, that's your pivot column. So when I look at this matrix here, the most negative number occurs right here. So this is the pivot column. All right. And what you're going to do is you're going to take the entry in the far right column of the matrix and divide by the corresponding entry in the circle column. But you don't use the bottom row. So you kind of ignore that bottom row. All right. So what we're going to do is we're going to take 37 divided by 7 and 42 divided by 8. I'm just going to plug them in a calculator. All right, let's see, 42 divided by 8 is 5 1/4, 5.25. And 37 divided by 7 is 5.28, 5.29-ish. All right. Now, what I want to do with this, okay, you're going to look at all the quotients, no matter how many there are, ignore the bottom row, all right? You want the smallest positive quotient, okay, no negatives, all right? And negatives you just ignore. So if I look at these two quotients, which one is smaller? Well, I know 5.25 is smaller, so I'm going to circle that row, all right? So my pivot point is the overlap of the column and row, so H right here is my pivot point, all right? So in the program simplex, you're going to tell them where the pivot point is. So the pivot point exists in row 1, right? Remember, these are rows, right? And it's going to be column 1, 2, 3. So row 1, column 3 is where your pivot point is. Okay, so let's take a look, and we'll find some pivot points, and I'll put a different video up there on run a problem, just so you can see me run one. All right, so again, we're gonna find a pivot point. That's what we have to find in this program, all right, that you will get. All right, so let me do this real quick. There we go, and let me get my pen up. All right, so first thing I'm gonna do to find a pivot point, look at the bottom row. The most negative number occurs right here, so that's my pivot column. So I'm going to do the ratios of everything above the bottom line. So 49 divided by 7 is 7. And 38 divided by -2 is negative, so you're throwing it out. Okay, no negatives. So therefore, since I only have 2 options, I'm going to pick 7. So 7 right here is my pivot point. So that's going to be in row 1, column 1, 2, 3, 4, column 4. Okay. All right, so that's all you gotta do. All right, let's take a look at this guy here. So pick the most negative value in the bottom row, that's -16. So here's my pivot column. All right, now pivot rows. So I do 45 divided by 7. Do that in the calculator. I get 6.428. All right, then I'm going to do 28 divided by 3. 9.3. And 40 divided by 0 is not possible, so we ignore that one. All right, that's pretty infinite. So the smallest ratio that I have would be 45 over 7, so this would be my pivot row. All right, so the row that I'm going to pivot around is row 1, column 1, 2, 3. So we're going to pivot row 1, column 3. All right, one more example, and then we'll end this 4.2. All right, so first thing, most negative number, -11. There it is. All right, do your ratios. So 8 divided by 1 is otherwise known as 8. 4 divided by -4, that's negative. So we throw out negatives. So that tells me again, row 1 is my pivot row. So this element here that I'm going to pivot around is row 1, column 1. Okay, so that's kind of a little bit about how to set up matrices in Blue. You're going to have to set up a bunch of inequalities through word problems. You're going to have to determine pivot points and matrices. And that's it for 4.2. All right.